Hello everyone, I'm Frank, and welcome to Learn How to Sudoku, where we take a very easy variant Sudoku puzzle and we break it down in detail so that you can learn how to Sudoku. Today's very easy puzzle is called Spring Break in Amsterdam by Chinstrap, and here are the rules. We have Squish Doku, where we need to place the digits 1 through 9 once each in every 3x3 box, without repeats in any row or column. Cells on region borders, that is dashed lines, are shared between multiple boxes. The way that I would like to put this, I would phrase this, would be that in every cell in the grid, place a single digit from 1 through 9, such that there are no repeats in any row, column, or designated 9-cell region. And this is a designated 9-cell region because, yeah, I guess you could say cells on region borders are shared between multiple boxes there too. But it just basically cleans things up, in my opinion. But that's just my opinion. I'm not a setter, so take my opinion with a grain of salt, I would say. So that's basically normal Squish Doku rules. We have Dutch flatmates, where every 5 in the grid must have a 1 in the cell above it or 9 in the cell below it. It may have both, but it does not need both. So say there was a 5 here, that would mean there would have to be a 1 above it or a 9 below it, and it could have both, but it doesn't need both. And that's an example of how Dutch flatmates work. And finally, we have numbered rooms, where outside clues represent the digit placed in the nth position, looking into the grid in the row or column, where n is the digit in the first position. So for example, say this was a 7. That would mean a 5 in this row has to appear in the 7th position, because this is the first digit. This is the digit in the first position. So therefore, in the 7th position, there must be a 5, right? Because the clue outside is the digit that must be placed in the nth position, which is the 7th position here, which would be a 5. So that's an example of how numbered rooms clues works. And those are all the rules. If you'd like to play along, there's going to be a link in the description. And now, I'm going to get started. Let's learn how to Sudoku. Okay, for numbered rooms clues, unless the clue outside the grid is a 1, the numbered rooms clue cannot be a 1, the nth digit next to the n next to the numbered rooms clue can never be 1 or the digit itself, right? Because if it were, the problem is that, say we had a 1 here. That would say 5 has to be in the first position when we know we have a 1 there, so that's not possible. And say we had a 5 here. Well, that would say 5 has to be in the 5th position when we already have a 5 in that position. So this is not possible to have a 1 or 5 in either of these scenarios. Same with any of these, same with these two. So this has to be either 2, 3, or 4, 6, or 7, right? Because we only have 7 columns in the Squish Doku. So this is 2, 3, 4, 6, 7. 2, 3, 4, 6, 7. And these are 2, 3, 4, 6, 7. Which means, where can the 5 be's in each of these rows? So, okay, if we had 7 here, the problem is this would have to be, that would be 5 in that position, which is not allowed. So this can't actually be 7. If we had a 4 here, that would work if making that a 5, but then this would have to be 4 also. So that doesn't work either. And if this were 3, that would mean this is a 5 here, but that would have to be 5 away from this cell here, which doesn't work. So this must be then 2, 6 as a pair here. So either 5 is 2 away here or 6 away. So that means 5 can only be in these positions. Where can 5 be in row 2? It could be 2, 3, 4, 6, 7 as possibilities. Same with row 3, 2, 3, 4, 6, 7. And this is also 2, 3, 4, 6, 7 as possibilities for the 5. This would have to be, could be, because this can't be a 5. Okay, where, maybe we should, instead of labeling pink, we should have where it cannot be for each of these rows. 5 cannot be any of these. 5 cannot be in 1 and cannot be in 5 here. No 1, no 5 here. This can't be 1 or 5 here. This can't be 1 or 5 here. No 1 or 5, no 1 or 5. So that limits where things can be. These all have to be in separate rows or separate. The 5 cannot be in the same spot. Okay, we are guaranteed, let's put it this way. We are guaranteed 3 5s in rows 1, 2, and 3. Because if we don't have 3 5s in rows 1, 2, or 3, then this wouldn't make sense, right? You have to have a 5 there. So this cannot contain a 5 because of this scenario in these cells. So this cannot be 3 or 4. So it has to be 2, 6, or 7 here. And this is 2 or 6 here. Well, where is the 5 going to be in this upper central box? Cannot be here, because if it's here, then that means we have a shared 5 amongst these boxes, which means there cannot be another 5 in those boxes, which means we would only have 2 5s in the rows 1 through 3. So this is not allowed. Therefore, in this box, this upper central box, the 5 has to be here. So this is 5, which means this must be 4 to satisfy the number of rooms clues, and this must be 6 to satisfy the number of rooms clue. So this has to be either 3 or 4 for the 5, and this is 2, 3, or 4 for the 5. But if it's on one of these areas, again, we have to have 3 5s in columns 3, 4, and 5. Otherwise, these digits don't work, right? So if this were 3 here, that would guarantee a 5 in the central box and this lower central box. And then this would not be able to be 5 because we would have a 5 there. So this can't be 3. Sorry, this can't be 5 here. This must be the 5 here. So that means this is 5, which makes this 4. You cannot have a 5 in the central box. And you can't be 5 here because of 5 in the column. Where is the 5 in column 5? Then it has to be here. So this is 5 here, which means this is 2 away. This is 5 this way, so this must be 3 away here. So where are the 5s then? 5 cannot be here. So that eliminates 5 from being here. Oops. This can't be 5. And these can't be 5 because of 5 in the row already. So where is the 5 in this upper left-hand box? It must be here. So this is 5, which makes this 2, which makes this 6. So this is obviously not a 5. So this has to be 6 or 7 here. Which means 5 is one of these two. Where is the 5? So 5 cannot be anywhere here because of 5 in the rows here. And we have 5 in the box here. And 5 in the box here. And again, cannot be 5 here because of 5 in the box and 5 in the row here. This can't be 5 because of 5 in the column, so where's the 5 in this lower left-hand box? It must be here. So this is 5 there. Where is 6 in this upper central box? 6 can't be here because of 6 in the row. 6 can't be either of these because it's in the same box here. And 6 can't be here because of 6 in the column. So 6 has to be one of these two cells. Well, since 6 is one of these two cells, that means this can never be a 6. Because if we had a 6 here, that would eliminate all possibilities for this being 6. None of these could be 6, none of these could be 6, and this couldn't be 6. So you would not have a 6 available in this upper central box, which we need because we need the digits 1 through 9 in all the boxes. So this can't be 6, this is 7, which means 7 away has to be a 5. So this is 5, this is not a 5. So now we need to figure out the normal squish Sudoku. 4 cannot be here. Where is 4 in this left central box? Can't be here because of 4 in the box. Can't be here because of 4 in the box, this box here. So no 4 here, no 4 here. No 4 here because of 4 in the column, so 4 has to be there. Let's see, 2. We've got all the 5s. Where is 4 in this central box then? Can't be here because of 4 in the column. Can't be here because of 4 in the row. Can't be here because of 4 in the box because of this 4. So 4 has to be one of these two cells. Okay. We are guaranteed a 4 here, so this cannot be 4 in the central box. 6 can't be here. Where is 6 in the central box? 6 can't be here because of 6 in the column. Can't be here because of 6 in the box. Can't be here because of 6 in the box, so 6 must be one of these two. Okay. We've got all the 5s. 4 is guaranteed to be one of these two digits. So therefore, 4 in this upper central box has to be one of these two digits. Oh, 5. Every 5 must have a 1 above and or a 9 below. So this 5 has to have a 9 below. So this is 9. This 5 must have a 1 above. This 5 has to have a 1 above because it can't have a 9 below it. So this is satisfied, this is satisfied, that's satisfied. You could have 1 above or 9 below, that's fine. We have a 1 here, which means 1 cannot appear in any of the 4 boxes that it's a part of. We have a 1 here. This 5 cannot have a 1 above it because of 1 in the box, so this must have a 9 below it. This 9 means this can't be 9 here because there's a 9 in that box. So this can't have a 9 below it, so this must have a 1 above it. Where is the 1 in this upper left-hand box? Cannot be here because of 1 in this box, so it has to be here. So that's 1. some nines. So we have ones. So we have ones in these boxes here. We have one in this box already, and this box, and this box, and this box. So we need a 1 in these cells. So this can't be 1. 1 has to be one of these two. We have 9 already in all of these boxes here. We have 9 here in this upper left-hand box. Where is the 9 in this upper central box? It must be one of these two. Cannot be here because of 9 in the row. So this must be a 9 there. That means we have 9s already in these two boxes also. So these have all 9 accounted for. Therefore, we need to have a 9 in this right central box. Cannot be here because of 9 in the row. So that means one of these two is a 9. So one of these two is a 9. We have one of these 3 as a 9. Okay. Remaining digits in this upper left-hand box are 3, 6, and 8. This can't be 6, though. That means the remaining digits in this box are 2, 4, and 7. And 7 cannot be either of these, so this must be 7. This can't be 2, so this must be 4, which makes that 2. So we have a 2 here, a 2 here. We need a 2 in this upper right-hand box. 2 cannot be here, 2 cannot be here. So 2 must be one of these two digits. So this is a 1-2 pair here. That means the remaining digits in this upper right-hand box are 3 and 8. So this is 3 or 8. This is 3 or 8. Remaining digits in this left central box are 2, 3, 6, 8, but 2 cannot be here or here. Whereas the 2, it has to be here. So that means this is 2, which forces this to be 3, 6, 8, 3, 6, or 8. Remaining digits of this lower left-hand box are 3, 6, 7, 8. Okay. This cannot be 3, 6, or 8 because of the 3, 6, 8 triplet in the column. So this must be 7 here, which eliminates 7 here and 7 here. This can't be 3 because of 3 in the row. This can't be 6 because of 6 in the row. Remaining digits in this lower central box are 3 and 8. 3 can't be here because of 3 in the row, so this is 8, which makes this 3. 8 eliminates 8 here, so it's 6. 3 eliminates 3 here, and this can't be 6, so it's 8. So 8 eliminates 8 in the box, so this is 3. 8 eliminates 8 here in the box, so this can't be 8. This can't be 8. This can't be 3 because of 3 in the middle box here, so this is 6. So it's 6 here, which eliminates 6 here. That means this can't be 6 anymore. Remaining digits in the central box are 7 and 8. 7 can't be here because of 7 in the column, so this is 8. This is 7. 8 eliminates 8 here, so this is 3, which makes this not 3. That's 8, which makes this not 8. That's 3. This is 8. Okay, in this right central box, the remaining digits are what? 2, 9, 6, 7. Okay. And this can't be 6 because of 6 in the column. This can't be 2 or 9. So this forces this to be 7, which means this can't be 7. That's 6. This can't be 6 or 7. This can't be 7. This 6 eliminates 6 here. So this is 3. Remaining digits in this lower right-hand box. We have 4, 9, and 8. 4 can't be either of these, so that forces this to be 4. This can't be 8 because of 8 in the column, so this is 9, which makes this 8. 9 eliminates 9 here, so it's 2 and 9. which makes this 1 and 2. And this 5 has a 9 below it, 5 has a 1 above it, 5 has a 9 below it, 5 has a 9 below it, 5 has a 1 above it, 5 has a 1 above it. And this obviously is in the second position, fourth position, seventh position, third position, second position, sixth position, fourth position, and sixth position. Having not done many squish dokus, I don't know how much of the logic is easy. Or very easy, I should say. So would I classify this as very easy? I don't know. If you've done a lot of squish dokus, I could see this being very easy. But I don't know if very many of us have done a lot of squish dokus. So that's not necessarily easy for us. Or very easy for us. I don't know. Maybe it definitely, if you've done a lot of squish dokus, I can see this being very easy. I just don't know if the general public is, or even people who do a lot of Sudoku variants, have done a lot of squish dokus. Maybe it should be classified as very easy. Because you just basically look at each box and then eliminate that way. I don't know. Anyways, let me know what you guys think. Was this very easy for you guys? Maybe, maybe not. But either way, I hope you enjoyed this episode of Learn How to Sudoku, and I'll see you next time on Frank Puzzles. Take care.